Good afternoon, everyone. Jeff Pearson here, along with Jason Miles, and we would like to welcome you to today's webinar, Incredible Innovations with Inventor 2016. And I'll challenge you up front to each say that 3 times really fast. We appreciate you taking the time to join us today. We're excited about the content that we have for you. This webinar is brought to you by Live Lab Learning, which is a subsidiary of Academic Corp, a wholly owned applied software company, and created to provide you, our customers, with world-class training. As I said, my name is Jeff Pearson. I'm an account advisor with our manufacturing technology group here at Applied Software, and I'm delighted to be with you this afternoon as your moderator. Throughout the presentation, we will encourage you, please interact with us, give us questions, thoughts. We're going to ask that you type your questions into the question pane. I will keep track of those as we move along, and we will address all questions at the end of today's presentation. We are also recording this webinar, and we'll make it available to all of you afterwards online via our YouTube channel. I would encourage you, if you haven't already, to search Live Lab Learning on Facebook and like our page there to get all the latest information and special offers. And when you visit the site, there's a complete schedule of upcoming training on a vast number of topics. Driving our webinar today is my esteemed colleague, Jason Miles. He brings over a decade of experience with Inventor to bear, and I'm sure many of you have spoken or worked with Jason in the past. We are pleased to have him leading the show for us today. So without further ado, I'm going to turn it over to Jason, and we will take it up from here. So Jason, you have the con, my friend.
All right, thank you, Jeff. So what we're going to end up talking about today is some of the new innovations of the R2 release. Now, first of all, what I'm going to end up doing is let me get logged into my vault here. And I'll share with you what we're going to be doing. All right. So, just to get an idea, we're actually going to be working on a piece of this welding station. It's fine. And once this comes up, there's a particular component of this welding station that we're going to be working on. It is actually going to be the component here, and this is known as the clamp assembly. And we were challenged to increase the throughput of this particular robotic welding station. Not only by doing this will the customer benefit from being able to produce more, the manufacturer could increase market share by offering better performing products and lower overall material and production cost. So the first thing that we're going to do is we're actually going to isolate or open this particular component just so you can get a better idea. So here's our component. We're going to end up going back into the vault and see what kind of modifications have, or needed modifications that have been requested. So you'll notice, if I go back to the vault, I have an ECO, an engineering change order. And I did receive a particular email with a GWIF attached, and you'll notice that if I go over to my Outlook, that I'm actually able to attach documents to this particular engineering change order. So let me see if I can find it here. So there's the GWIF that I received. And once this opens, I'll get it into the vault here. We'll give that a second. But other thing that I'll show you while that's opening is notice how I can directly review or just take a look real quickly at some other documents that are within this ECO. So you'll notice here I got a kinematic diagram of our assembly that we're going to be working on. Also, I can attach, like I said, emails right here directly within the vault. So that's pretty much giving me an idea here of what we need to modify. And it looks like that my email's slowing down on me a little bit. So let's see. All right, let's try this again. What I want to do is, because the email that I was sent was an actual markup of what actually needs to be changed in regards to that clamp assembly. So let me see if I can get that open again. There we go. There we have it. Now I want you to notice within Outlook, notice that I also have the Vault tab within here as well. So let me go ahead and log in again. And what I'm going to end up doing is I'm actually going to check in this particular email and the attachment. So let's go ahead and check this in. That'll be fine. And then once that's checked in, I can go back to the vault. And I know that's at my top level. And notice that I can actually attach this to that change order. And I'm just going to do a basic search, and that's one of the good capabilities within Vault. So notice there. And then if we go back to that ECO, notice here I actually have that GWIF. Now, when this opens, notice that the markup that we currently have. So it looks like they want us to optimize the upper clamp assembly for improved cycle time without the loss of structural integrity. And also they want us to determine the proper hydraulic cylinder to maintain 300 newtons of clamping force. All right, so once we have an idea of what we need to do, we can actually go ahead and we're going to do a couple searches here. All right, so I'm going to use one of the find capabilities again within Vault, and what I'm looking for is actually the assembly that pertains with this number here. So I'm going to add some search criteria. So I'm going to go for, let's say, files, and let's look at file name. And you'll notice I'm just going to copy that number. All right, we can add that. And then I also want it to look for that number and also that ends with the extension IM for the Inventor assembly. All right, and we'll notice that here is that main assembly that I'm wanting to utilize. Now, another great feature here that I'm going to use is the copy design capability. Now, with this particular model loaded, we'll see that it contains all the parts that it consists of. Also, just want to double check and make sure that I have my particular numbering scheme set up, which I do. So once I have that, we can go ahead and I'm going to just right click and say copy. That way when I come over here and look, we'll notice that this is my new file that's going to get created with a sequential number. So we'll just go ahead and create that copy. All right, so it's finished, it's happy. So let's go back and let's find that particular assembly. So we'll notice here, there's my newly created assembly. And I'm going to go ahead and perform a get on this particular assembly just so I can get it into my Vault workspace on my local machine. Now what we'll end up doing is let's switch over to Inventor. And we'll close out of some of these components here. Let's leave these open just for a little bit. Okay, I'm going to leave that one open. And I'm going to actually go ahead and find our new assembly. So we just made a copy of it. Now remember, one of the task that was assigned to us was to determine the force required to maintain a 300 Newton clamping force at the other end of this upper clamp. Okay, so I'm going to just verify that I have everything checked out. Okay, everything looks good. Now, the way that we're going to accomplish this is we are going to be using a new feature that is in the R2 release known as force effect. Okay. So I'm going to go ahead and I'm going to create a new sketch. This is where we can go in, and you might have been familiar with force effect on the iPad, but now they've incorporated it directly within Inventor. And you'll notice up here that I have a force effect panel. So let's go ahead and create a new force effect diagram. Okay, within here, I want to go ahead and let's save this. Maybe I'll call it layout. Clamp assembly 1. That'll work for me. And we'll go ahead and save that. And now you'll see that we are in the force effect module directly within Inventor. So the first thing that I'm going to do is I'm going to place a background image of our assembly. And this is just a snapshot that I took of this particular file. right, so there's our image. Now the next thing that I want to do is I want you to note that initially these elements in force effect are scaleless. Okay, so it will come in as a nominal scale. And in this particular case, go ahead and zoom in a little bit. I'm going to set the initial scale to 4.25. Now what I can do to lock this in is I'll just click on this and you set the length basically just by entering data. So I'm going to go ahead and set this to 190 millimeters. And then I'm going to add another element between these 2 points here. And that looks like that will work. Now, even though I'm wanting 62, I still need to go ahead and click on that length and choose OK. This is what locks it in. All right, and then we're going to add one more element, which is actually going to represent the backbone structure. And this one's going to be 455. Now keep in mind of what we're doing here, which is essentially a free body diagram that will represent how this mechanism functions. So the next thing that we'll end up doing is, let me go ahead and zoom out a little bit here. Okay. And I'm going to create what a fixed, or actually a ground support. So I'm going to tell it that it's grounded down here at the bottom. So there, we know that that's grounded. So the next thing that we need to do is I need to add a welded joint to these two top elements right here. And what I'll end up doing is you'll notice how user-friendly the menus are. So I'm just going to right-click up here on this particular joint. And notice I can insert a welded pin. Now you'll notice up at the top, right now I'm in the static environment. I can switch it over to the kinematic environment, and just so we can do a test and see the type of motion that I'm getting. All right, the next thing that I want to do is, well, I'm going to go into my document settings and I'm going to modify my force units. We want those to be newtons. Now, if you'll notice, this was red up here at the top. Okay? You'll notice that it's green now, letting us know that this is in the state of equilibrium. If I go back to the static environment, notice what we have. It is no longer in an equilibrium state, but an indeterminate state. This is because we have yet to assign any forces. So let's go ahead and continue doing that. All right, so I'm going to go over here and start assigning some forces. And the first one that I'm going to do is I'm going to add that 300 Newton force, which will be our clamping force here on point B. And the next thing that we have to do is we're going to use an unknown force on point A to determine how strong of a hydraulic cylinder is needed to generate the 300 Newton force. So as of right now, with this being at a 90-degree load, you can see that it's saying that I need an actuator that can push 827 newtons. All right. Now, so with that being our requirement of 827, this will actually change based on the angle of this particular force. So I'm actually going to select this force, and I'm going to change this angle. I'm actually wanting to change that to, let's say, 82 degrees. Okay. Now, notice that it's saying right now with that, actually it's an actuator, it's saying that I need an actuator that can handle or push 927 newtons. And what we're going to end up doing here shortly is we're actually going to go and find an actuator, and I'm probably going to look at one that for probably 1,000 Newton actuator. All right, so once we have this, let's go ahead and take a look real quickly, and let's look at the report that we'll get. So this is the report that it generates. Okay, just to give you an idea of all the information that is shown. So there's a lot of good information being shown within this report. So now, let's go ahead and save what we have so far. And I'm going to go ahead and close out of that. And the great thing is all that information is saved within our assembly and the sketch. Now remember, I said we have to find a actuator, and I've already downloaded one, but I want to show you where I got this from. Parker.com. I got this from the Parker Hannafin's website, and they have an online configurator. And what I ended up looking for was a 3L medium duty hydraulic cylinder. And with this particular website, I can actually get Inventor models directly. So for instance, the great thing is you'll notice that I can go through and configure exactly everything that I'm wanting to get from here. Okay, and like I said, I already have this already set up. And then once you make all your choices, you can generate the CAD and it will be emailed to you. Okay. So let's go ahead, and I'm going to go to the location where I have saved that particular document. right, and let's put this in my workspace. Okay, that's going to be in special, and let's put it in purchase parts. All right. So since I have that in my workspace, let's go ahead within this our newly copied design assembly, and let's replace this actuator. Okay. And we're just going to do a component replace. A5. That looks good. All right. So currently, our first task was to find an actuator that fit the needed requirements. So we've done that. And notice that I'm staying in Inventor most of the time here because I can switch to the Vault browser, and you'll notice that that new actuator needs to be checked in. All right, so let's go ahead and check in this actuator. And I'll go ahead and possibly enter a comment down here at the bottom. And I'll just say something like initial check-in. Okay, so now that is currently up in my vault. Okay, and now the next thing that we're going to end up doing is we are going to be working within our main assembly here. So for instance, 200.103. Let me collapse all this. 2.1. Okay. And this is what we're going to end up working on here, is that top or that upper clamp. So I'm going to go ahead and open this. We'll give it a second. And what we're going to end up doing is with this part, we've already spoken about the force effect, which is new in R2, but there's also another new improvement or feature or capability within Inventor called Shape Generator. Okay. Now, what I'm going to end up doing is let's move my end of part marker up a little bit. Now, what Shape Generator essentially does is it takes analysis to the front of the design process. So I'm going to go in here and let's finish this. I want to actually make some modifications here because what Shape Generator is going to do, I want you to think of this as my stock material. Okay, so I'm going to oversize it just a little bit. Okay. And really what I'm doing is creating a volume for Shape Generator to work within to create the geometry that I am needing. Okay. Now we'll go back into the shape generator, and the way that it works is that it utilizes the stress analysis environment. Like I said, by moving it up front, and it actually balances metrics such as factor of safety and, in this case, mass, to optimize a design and to essentially leave you with the minimum amount of material to meet our design criteria. So I always like the way that the interface works. It's really a left to right type workflow, or if you're more comfortable with the browser, top to bottom. So I'm going to go ahead and let's go ahead and set up a override material. And I'm going to select alloy steel. And I'm going to continue, like I said, moving from left to right by adding some constraints. So I'm going to add a pin constraint to this location here. And then we're going to continue, and I'm going to add a frictionless constraint over here on this end where it clamps. Now the next thing that I need to do is I'm going to add a load. I'm going to add a bearing load, and I'm going to set this up with the information that we gathered from Parker's website, when the actuator that we chose is 1,000 newtons. So I'm going to go ahead and set that up. Now let's choose the location we're going. That looks good. Okay. Now the next thing that I'm going to end up doing is I'm going to use this preserve region. This is which specifies the regions of the model to exclude from the shape generation process. Okay. So I know I'm wanting to keep some of these features here. All right, so once we have that, I'm going to modify this because my mass target, I want to reduce this original part here. I want to reduce it by 75%. Okay. Now, once we have that, the next thing is we just need to run it. So we're going to generate this shape. Now, what this generate shape is currently doing is determining what the minimum amount of material that is needed to satisfy our requirements. Okay, and once that's done, we'll see what it says that our part should look like. Okay, and there we have it. So our job now is to change this part so that it mimics as close as possible the results of the shape generator, which we can then promote to our browser history. So you'll notice I can promote this particular component. So I'm going to do this current part file. And you'll notice that I have it listed over here in my browser. So let's turn on some things that's going to make it a little bit easier for us to see our model. Now what's left now is we're actually going to go in and we're going to utilize just our basic sketching and extruding to mimic this shape. So I'm going to start a new sketch on this face. And of course we probably need some geometry here. Okay. And then I'm going to go around and just start creating some geometric entities. All right. Now once I have this, when I finish this part, we'll end up running some additional analysis just to validate the design. And we're going to be utilizing the Autodesk Nastran NCAD. So I'm pretty confident that this design will function properly because the shape generator is an analysis-based tool to begin with. Okay. All right. And you'll notice I'm just trying to mimic this shape as closely as I can. And using some of our basic geometric constraints. Right. And then once I get this sketched in, I'll go in and I'll add some dimensions. Okay. And let's say, for instance, I'm going to add, let's say, a 15 millimeter there. Maybe a 9 millimeter. Okay. And let's go ahead and offset this here. All right, it's looking good. I think I already have that one. I do. And notice I'm just referencing the 9 dimension that I've already added. All right. And we'll see what this looks like once I trim it up. Somewhere in there, looks pretty good. And let's go ahead all right, almost there. I'm going to keep this unique thickness all the way around. That'll work out good. Okay, so I have one more left to attach, and it's this centerpiece here. Okay. All right. Let's get that somewhere over in this location. Now, you've probably heard that saying or that phrase, the future of making things. Well, I'm going to tell you, that's what we're actually doing right now. Some pretty amazing stuff. And let's see. There we go. All right, good deal. All right. So now that we've got it pretty much sketched out the way that we want it, let's go ahead and finish this sketch. And let's cut out some of this material that we don't need. Okay. So now with this, what I'm going to go ahead and do is I'm going to turn that visibility off. Oh, it looks like I missed an extrusion here. One more piece that I want to modify. Okay. All right. So let me rotate this around just a second. All right, looks like it grabbed that. Looks like I need to modify something real quick. Visibility. Oh, there we go. And let's see if I can grab. There we have it. All right. And currently, this is our part. Now I'm going to clean it up just a little bit. Go in there and soften some of the edges. So I'm going to go in and add a fillet. And I'm saying 10 on the radius will be fine. Okay. Oh, okay, so we can fix that, no problem. Looks like we got our hole. So you can see that we have to go and just do just a little bit of modification here. And let's just move this back just a little bit. Okay. And let's see what it's showing us here. That's still part of that sketch. Okay. Oh, I see it. Let's try that one. Okay, got that fixed. We're going to fix that hole just a little bit. That's not a big deal. We can have this change the depth just a little bit. Let's give it a second. Okay, so let's drop that down probably about, say, 21. Okay, still not enough, so we'll modify that one as well. There we go. Now let's go back and add those fillets. Okay, that's looking good. All right, and then I'm also going to go in and I'm going to soften up some of these edges here. There we go, just like so. All right, so using the shape generator, I'd say that we have our part, a totally new upper clamp. And the beauty of it is that the shape was determined by our analysis tool. All right, so let's go ahead and save what we have. And I'm going to go back and switch to our upper clamp assembly. So you'll notice there we have our new clamp. Now, another thing that we want to do is I've already spent the time for this lower clamp body here, and I use the generate shape as well. So I'm going to go in and we're actually going to replace this with the new design that I created. Okay, and let's go on up here, designs, and I put it in the parts. And let's change this to IPTs. Okay, there's my base. Okay, starting to really come together now. Now, the next thing that I want to do here is I want to go ahead and make sure that I get this information into the vault. So I'm going to go ahead and check in this particular clamp assembly. And you'll notice what's getting checked in as well. See my results, my FEA results from the shape generator. Those are getting checked in as well. I'm going to go ahead and add a comment here. And let's say updated to include shape generator input and replace the Parker PCS actuator. All right. So now I need to go back to my top level assembly. And we're going to go in here and we are going to perform a replace here as well. And you'll notice that this particular clamp assembly is used multiple times. So let's go ahead and let's do a component replace all. Let's activate this first. There we go. And we are going to replace it with our new assembly. (101) (103). There we got it. Now, you have to admit, with a short period of time here, we've done quite a bit or a significant amount of light weighting to the clamp assembly. So the next thing I want to do is I want to go ahead and get this assembly into the vault. let's go ahead and save what we have. And I'm going to go ahead and check in this top level assembly. Okay. Now, just to keep everybody informed on, the process that we're going through, if anybody else comes and takes a look at this model after me, that's why I always like to go in and add some comments to include with each version. So for this one, I'm going to say updated assembly to include the lightened clamp assembly. And I'm going to go ahead and say OK there. All right. Now there's one other thing that we want to do. So we've made our part a little bit lighter. We've changed the actuator to meet the requirements, but I want to focus a little bit more on that upper clamp that we just created. So what we'll end up doing is we're actually going to take our testing a little bit further. And this is where we'll go in and utilize some of the Nastran in-CAD capabilities. All right. Now, let me go ahead and open this part directly. And I'm going to go ahead and make sure that I have this particular part checked out. And I'm also going to go ahead and grab these FEA results, check those out as well. And I'm going to go in and I'm just going to create just to set up a static analysis just real quick. So I'm going to go ahead and set my locations up again. And I'll show you why I'm doing this in just a second. And let's go ahead and make sure. So still alloy. All right, and let's go ahead and add that bearing. And this is 1,000. Zero, zero. There we have it. Okay. So I'm going to go ahead and run this just real quick. Shouldn't take long at all. All right, so I'm going to take this over to Nastran is because I want to just import some of the stress analysis real quick. And what you'll notice is that that stress analysis information came over. Notice I have my pin constraints, my frictionless, and my bearing load. So what we're going to do is we're going to start out, and we actually want to do a fatigue study. So I'm going to change this to a fatigue study. Okay, so we got a multi-actual fatigue analysis going now. And we're just going to go and we're going to modify a couple things. So I'm going to go in and I'm actually going to create maybe one or two more constraints in here. And this is what this is going to end up doing is this is going to represent the pin in this particular location. Now, one thing I do see that I'm missing is my sketch that I want to utilize, so that's not a problem. So I just went back and turned it on, and now we're good to go. So here, I'm going to change it, let's say, to a rigid body. Now, this is only able to rotate going around this axis. All right. Now, within the mid-year release of Nastran NCAD, you'll notice that they've incorporated the right-click radial menu and the overflow menu, which I really like. So we're going to go in and start adding some constraints. So here, I'm going to grab that center point, and what I'm wanting to do is, like I said, it's able to rotate about this axis, which is my Z. So I'm going to uncheck that to allow that degree of freedom. And we're going to continue going in and doing just a few modifications here. Now, usually with the fatigue study, I'd have to come in here and I'd set up, a new table. All right. So with this, I'm going to do it load scale factor versus time. I'm going to go ahead and set this up. Zero, 1, and 0. And let's see what we have. So what I'm showing here is it's loading and then it's unloading. Okay. All right, the next thing that I want to take a look at is I want to add, notice that my material came over. So I actually want to add this material up to my model, okay? So this is where I can just drag it up here to the top. Okay, there we have it. And let's go in and let's take a look at this real quick. Okay, so looks like everything's in order here. Another thing that I want to do is I want to input some analysis-specific data. So for my fatigue table, we'll enter in some data just real quickly. Okay. All right, so once we have that, I'm going to go ahead and just a few more changes, and then we're going to run this analysis. Okay, for my fatigue setup, we're wanting to look not at stress life, but the we are going to look at the stress life, but what I wanted to change in here was my method. I want to look at the von Mises. That's the way I want it to solve. And then change my element size. Usually 5 millimeters works pretty well, so I'm going to start there. Okay, and then once again, with my right-click menu, we're going to run this. Okay. So let's go ahead and take a look at our stress. Okay. Overall, it looks like we have, a pretty strong part showing here. Nothing too detrimental showing. But I want to take a look at this damage contour, because really what we want it to do is actually we want this part to last for 300,000 load cycles. And with this, on the damage contour plot, you'll notice is we will see the 0 damage for the life of this component. Right. So it looks like we have a good part that came out with the new R2 release with the shape generator. And I hope everyone has updated their or downloaded the R2 update. So the next step is, when we're completed with this, is to just get everything back up into the vault. Okay. So we'll go ahead and check in all of this. Same thing. Looks like everything is good there. And everything here is good too. So we can go back to my vault, just do a refresh. Notice that we have everything checked in. You'll notice here within the vault, I look back on that new assembly, notice that I have comments that I've added. So anybody that has access to the vault can come in and see what's been changed and updated. So I hope you enjoyed seeing some of the new stuff in the R2 release. And as of right now, I'm going to turn this back over to Jeff.
I want to thank every one of you for spending the time with us today. I know we ran a little bit over, but this is an exciting new release packed full of new features and capabilities that hopefully can make your jobs easier. Thank you to everyone for joining us. Have a great afternoon, and we'll see you next time.